So hi friends, welcome to my channel in Leetcode. So आज we'll be solving this problem for unique paths. Okay, so let's go through the question first. So the question says there is a robot on a M cross N grid. The robot's initially located at the top left corner, that is grid 00. The robot tries to move to the bottom right corner, that is below 1, or the robot can move to either down or right at any point in any time. So we are given the two integers m and n, and we have to find the number of possible unique paths that the robot can take to reach the bottom right corner. So we have to get all the possible unique paths that the robot from the start can reach to the finish point. So that's the question. So we have the m and n. So this m and n are the two integers that have been given. Okay. So okay. So this question looks the difficulty level is basically medium given over here. However, it looks quite easy to me. Let's solve this problem first. So we'll move to the DP approach later on. First, we will go with the basic approach of how to solve this problem. Generally, so we see that the robot can take either the left or the right. So it can move either in the right side first, or it can take the down bottom one. Okay, so there are two movements basically the robot can take. So basically it would be in the right side, or will it be in the down one. Okay, so anywhere in the left side if it moves, so that will be a lesser number of chances of it to reach to the finish path. Okay, so we will be considering only the two possible paths, that is either the robot would move in the front, that is on the right side, or it will move on the down one. Okay, right. So let's go. So generally by so this kind of approach, the way where we're doing the repetitive tasks again and again, is basically a way of recursion. So we'll try solving this problem by recursion. Okay, and then we'll move to some other approach. Okay. Okay. So first of all, let me create a TP array basically, right? So we have your okay. So the difficulty level for this question is generally they're given to be medium. Though I didn't felt to be a medium level question. Okay. But yes, if you're new to it, it might look a bit difficult. Okay. We will discuss this approach once I'm done with the code. Okay. We will come back again. Right. So what I'm doing over here is basically I am using the recursion over here, and I'm trying to traverse the DP array basically again. And so recursion, basically in recursion we do have an helper function always to do the recursion. So let's say we have an helper function, and we declare the integer I and j for the traversal, right? And we will be using the DP array again. So let me define it again. So let's go with an answer basically. So we will return this answer as the number of possible ways the robot can take and come back to the endpoint. Okay. So what is the first case where we can reject? So these are the edge cases which we have to reject. So what are the cases? So let's say um, um let me open the board. Okay. So let's say we have, right. So this is a square board, right? Okay. So if you see, the robot basically is in the first place over here, or it may be any of the places, right? And it has come down to the endpoint. So it can take this travel, or it can go down. Again, it can go this, or it can go down. Again, it can go this. Again, it can go down. But wait a minute, will it go down? No. Why? Because it has reached the edge cases, right? It cannot go down, so it has to take a right again, right? So it again takes a right, again takes a right. So it will stop again, and finally it will reach that point. So what are the edge cases? So anywhere if it crosses the boundary cases, so it has to revert back. It cannot traverse those edge cases, right? So we have to remove those edge cases. So what do we do? So over here, what we'll do? So if I is greater than m, if we have this, or if we have j greater than equal to n, right? So these are the places where basically we will not get anything and we will return back, right? So what are the other cases we can? So anywhere while traversing, okay. So this is my base case, right? So anywhere if I'm traversing and if I'm getting my endpoint, which is the corner, the edge, the end one, right? Anywhere if I'm getting this, so right, what will do? Will return back one over here, right? So every time we return, we go back to the finished one, so we'll be adding it a one over there, right? So this is the base case of me. Now in the end, what we'll do, we'll call up the recursive function again, and what we'll do, we'll pass the elements, right? So we will pass the same. So we are this one, we the right one. This is the first traversal we are doing to the right, okay? So we will do this. We'll pass again the same elements will repeat, right? We'll pass again, and the other one, what is the other one? So either it can go down, right? So it can go down with the same elements again, no change in that, right? So and what at the end what we do? So we will return your answer, right? So let's run this code first and let's see. Okay, so we have a vector recursion returned unused value to 0, 0, mn and repeat, right? So what is the ls value for here? Okay, so we have not called the function, right? Let's run it again. Okay, it's accepted. Let's submit it. Okay, we see that it's a TLE, right? We get the TLE, a time limit exceeded, right? Over here. So why we are getting this time limit exceeded over here, right? Because let's go back again and let's see. Okay, so if you see this again, um, let's write again. So let's say, so this was the square box, right? Which you are doing the traverse with, right? So what it is doing, so let's say it is when it starts, let's put go right, then again go left, again it go right, right? Again over here it will take a right or it will take a down. Again from here it will take a right or it will take a down. Right, from top also if it comes, if you see that it's going to the right, again it's going to the down, again it's going to the right, again it's going to the down. So see, we see that similar steps are repeated again and again, right? So those cases are basically giving me a TLE over here because I'm doing the same cases again and again and I'm passing it again and again. That's why we're getting a TLE over here. So what can we do in this case? So whenever we have repetition of the same steps again and again, the best way to solve this one is using a DP array, right? We can solve it using a DP array. So what we'll do? So all those cases, right? We basically use a DP array. So we have that DP, right? And we have those particular defined. If anyway I'm getting not, if it is not defined, right? I'm gonna repeat. I'm gonna send back the same elements again, right? So let's say if anywhere I'm getting the DP which is not defined, right? So this is the new one. This is a new step basically I'm moving into. So in that case I'll return that DP array anywhere, right? Now what is the other thing? So let's say if I've already calculated that step, right? If I've already calculated that step before, so what is the use again? So I don't need to recalculate it, right? I can send it back again. I can send it back the same DP array for the calculation, right? Let's run this. So we do this. Okay, so we are getting one. Okay, so we have the ing node, right? Okay, so this is not equal to, run it again. Let's see. Okay, it's taking accepted. Let's run it. Okay, so this is accepted. It has accepted the solution. So basically, this DP array has worked over here. All those TLE cases which we're getting for the repetitive tasks, so that has been taken care by the DP array over here. So that's all for this unique part. I hope you like this solution. Please do like and subscribe to my channel if you like my solution. Thank you and have a nice day. Bye bye.